So let's do the 2018 paper and see whether we can do as much as possible. Right. So I'll be doing a little bit slowly because this is our first paper officially, but we will be making it faster and faster. Okay, faster and faster. Right. Question number 1. So I don't want to do a revision on these topics much because you have the recordings. So if you don't have the recordings, physical classes, yes. But since you have the recordings, I don't think that I need to do the same thing over and over. Okay. Right. So therefore, my task is quickly do these questions and prepare you for the exams. Okay. Right. Consider the following 3 numbers in decimal, octal, and hexadecimal notations. Maybe we have done these questions while we do the topic as well, but anyway, we'll do it. Which of the above is equivalent to 111001111? Okay. So remember, it's easier to convert. You can see that multiple answers are also there anyway. So therefore, we need to convert each and every one and see. Okay. Right. So therefore, let's first convert. Easier thing is convert this to this. Okay. So be tactful. Right. So rather than converting this to binary, converting binary to denary is easier. So therefore, anyway, it's usually easier. Therefore, I'll do like that. So this is 1, 2, 4, 1, 2, 4, 8, 16, 32, 64, 128. That is 128 plus 64 plus 32 plus 4 plus 2 is 6, 6 plus 1 is 7. 8 plus 2, 10, 17, 21, 2, 4, 10, 13, 1, 231. Yes. So this is correct. A is correct. Then I will convert the second one because it's easier to convert binary to octal. Or actually, both are easy anyway. But I prefer to convert it to binary to octal. So take it 3 by 3 from right hand side. This is 7. This is 1, 2, 4. And this is 3. 3, 4, 7. Yes, this is correct. So then I will convert this to 16 because that is easier for me. I need to take from the right hand side 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. This is 1, 2, 1, 2, 4, 8. This is 7 anyway. This is 1, 2, 4, 8. That is 8 plus 2, 10. 10 plus 4, 14. So what is 14 in hexadecimal? A, B, C, D. 10, 11, 12, 10, 11, 12, 13, 14. 14 is E. So therefore it is E7. So therefore all 3 are correct. So the answer is 5. Answer is 5. Answer is all 3 are correct. 5. Let's double check the answer. Yes, answer is 5. Okay. Right. So if you have any questions or doubts, you can ask. Otherwise, I will just move forward, right? Assuming that you understand everything. So therefore, the moment you don't understand anything, you need to just disturb me so that I can tell what is your issue or which one you don't want to explain more. I will do it. Right. Question 2. What is the decimal equivalent to this number? That is super easy. So we did this kind of question. So convert this separately and this part separately. So this is 1, 2, 4, 8, 16, 32. So that is 32 plus 16 plus 4 plus 1. That is 10, 12, 13, 1, 4 and 1, 53. So then this is 0.5, this is 0.25. Or half, 2 to the power minus 1, half, 2 to the power minus 2, 1 over 4. That is 0.5 and 0.25. 0.5 and 0.25 is 0.75. 53.75. Answer is third one. Second one answer is third one. Okay. Answer is third one. Third question. Which of the following describe the term telecommuting? So this is general knowledge, right? So you must know what is telecommuting if you are living in 2024. So, okay. So what is mean by telecommuting? So that is a general knowledge question. Ability of an employee to perform duties conveniently from different geographical locations. So basically, telecommuting means work from home. But anyway, as a general term, we can use it for any remote work. But mostly, the word telecommuting is used to convey work from home. But it is not strict to the work from home, anything that you do remotely. But mostly, we take it for the work from home. So therefore, this is okay. But let's read all five, because only one answer must be correct. Or then you need to find the best answer. Having online meeting with people at different geographical locations. So as I told you, this is also sort of a telecommuting, but work from home or work from remote location is the most suitable answer. Okay, so therefore still I will stick with one. Using ICT for community services. No, that is not telecommuting. Using web-based application to retrieve information. So that is not telecommuting. Performing financial transactions online. So basically telecommuting means doing something, right, like a work remotely. So therefore we'll go for one. We'll go for one. So the third one answer is one. Fourth question. Consider the following statements. Word size is the number of bits processed by CPU of a computer in a single action. So remember, word size is, if you take memory, so the old memory is byte addressable. Every byte has a memory address. But these days, logical address is given to not just 1 byte, maybe 2 byte, 4 byte, and so on. So that chunk of data that we can transfer as a one unit to the data bus, and also which we can process in the processor, is called word size. So in modern computers, the word size is usually more than 1 byte, maybe 2 byte, 4 byte. Okay. So that is why the data bus width is equal to the word size, because we want to send that chunk in a single clock cycle to the processor. And registry also has the same word size, because the particular registry can keep that data. Okay. So therefore, what about the A? A is correct. Word size is the number of bits processed by CPU. So that is why we want to take the entire chunk to the processor in the data bus so that it can be processed. So your word size is how many bytes has a memory address, and your registries must also have the same size so that that data can fit into a registry location. And your ALU must support processing that size value in a single clock cycle or single passing. So therefore A is correct. So basically, you know that there are 32-bit operating systems, 64-bit operating systems. So old operating systems are mostly 32-bit, but modern operating systems are mostly 64-bit. So that is also sort of the word size. So your operating system can process 64-bit data or instruction in a single passing. Okay. Right. So the B, data bus width and registry width are directly related to word size. So that is exactly what I told. Your word size, your data bus width is also equal to word size, so that that particular data or the content of that memory location can be taken to the processor in a single clock cycle. And obviously, the registry size must also be the word size, so that registry can keep. If this is 2 byte, your registry must also be able to keep 2 bytes so that this data is kept there in a single registry. So that is correct. Word size of modern general purpose computer is either 34 or 64-bit. Yes, right? So 32-bit is now a little bit outdated, but most of the OSs are these days 64-bit. But still, there are 32-bit support. Okay. So yes, so mostly it is 64-bit, or we can say 32 or 64-bit. So I'll go for all. Fourth one, all. Yes, all means 5. Okay. Fourth one is 5. Right. If you have any doubts, you need to talk. Otherwise, I will proceed. And the other thing is, now when we did some of the topics, you had all the notes in your Google Classroom, but I have updated most of these notes. So therefore, make sure you take new notes frequently, right? Frequently, but so that you have the latest notes, okay? Latest notes, especially web development, database, networking. So networking in the coming weeks also I will be uploading, right? But I will try to inform you as much as possible when there's a new change from at least from today's onwards. So therefore, I heavily recommend you to get all the notes again from the Google Classroom. But from maybe from this week onwards, I will tell you because otherwise you can't go and download the notes all the time. If there's a new version, I will let you know. Okay, fine. So this one. So this is related to security. In public key encryption systems, each pair of communicating entities share a single key for the encryption and decryption. Right. So I think we discussed about private key versus public key encryption. Maybe I can again explain you a little bit again today. Right. So therefore, let's keep it open for the time being. Phishing is, remember, phishing means you try to fool someone by pretending someone else, like, right? So the common things are saying that you have won a lottery and to transfer, give us your credit card number or initially do some deposit, right? So that is phishing. Okay, phishing. So you fool someone online through email, SMS, and so on. So phishing is a type of social engineering. Yes, so that is called social engineering, manipulating people, foolish people, or people having lack of IT knowledge, common sense. Right? Yes, it's a social engineering approach. Social engineering attack often used to steal user data, such as username and password. Yes, username, password, credit card numbers. Okay, so I'll go for yes. Okay, I'll go for yes. Port scanning is right. Port scanning is a method which can be used by attackers to identify open ports or services on a network. Remember, the port numbers are the running programs numbers. For example, if there's a web server running, the port number is 80, and so on. So the HTTP we have SMTP there's a port, POP there's a port, FTP there's a port. So port scanning means basically uh, that a possible attacker try to identify which port that particular machine is running. So then if for example, if port 80 is there active, that means there's a web server. Most probably there's a web server. So likewise, the attacker can get some insight by identifying which ports are running. Okay, which ports are running. For example, right now in my machine, 80 is not running. But if I start SAM or my Apache web server, then of course, from this point onwards, port 80 is now running on my, you can see port 80 and 443, HTTP and HTTPS. So now someone in the network may be able to send a data packet to the port 80 and check whether it is accepted. So then it knows that yes, web service, there's a web server running in this machine. Okay, so that is called port scanning. So port scanning is a method which can be used by attackers to identify open ports or services. Yes, running services or open ports. So same. Okay. D. Digital signature can be used for email message authentication. Yes. Okay. Right. I will again briefly explain what is digital signature, what is encryption, decryption, public key, and private key. Okay. But let's look at this one also. In public key encryption system, each pair of communicating entities share a single key. No. If single key is shared, it is not public key, it is private key. So therefore, this is wrong. So therefore, answer must be B, C, D. That is fourth one. Let's double check the answer. Fifth one. Yes, answer is fourth one. Okay, answer is 4. Right. So let me briefly explain this again. Okay, very briefly. Right. So remember, when it comes to likewise, while we are doing past papers, we will do some topics. We will take it to a sort of a quick revision. Okay, quick revision. Right. So this is related to security. Right. So when it comes to security, so what are the 4 aspects of security? Now you must talk, because now you guys have applied for the exams and now you guys are waiting for the exams, right? What are the objectives of security? Availability. What else? Confidentiality. What else? Integrity. What is the last one? Anyone? Yes, integrity. What is the last one? Non-repudiation. Non-repudiation. So availability means resources must be available. For example, virus attack will try to compromise availability. So it will destroy corrupt the files. So that is availability is compromised. Or maybe DOS attack. So when there's a DOS attack on a server, the genuine users cannot use the system. So the system is not available for genuine users. So again, availability. Then confidentiality is you try to steal sensitive data. You hack and get some data. You hack a database and get data. Or you hack someone's password, credit card numbers. So that is you compromise confidentiality. So attacker has compromised this property. Integrity means attacker somehow change the data without the notice of the server or whatever. So data is modified. Modified data is sent, but that modification is done by vicious party, third party. That is called integrity. And non-repudiation means when someone has not done something, that person claim that he has done it. When a person has done something, that the user again claiming that I have not done it. So we must prevent that. So that means we want to safeguard non-repudiation. If you haven't done something, you must not be able to claim that you have done it. If you have done it, you must not be able to, we must be able to prove that yes, you have done it. So those are the 4 aspects. Then how do you enforce security? Right. Basic approaches are authentication, authorization. So having some digest or hash, okay, or checksum, that is for integrity. A checksum, or we can call it hash, or we can call it digest. Use of checksum, hash, digest. Okay. Another one we can do is encryption, decryption. Encryption, decryption. Of course, the decryption is a reverse process. Then, of course, there are some other things like prevent DOS attacks by having something like firewalls. We can monitor the network. We can have virus guards. So those are also there. Okay. So virus guards, firewalls, and monitoring and so on. Okay. Authentication, authorization, checksums, hash or digest, same thing. Encryption, decryption, virus guards, and any other monitoring. Right. How do you do the authentication? So there are 4 ways you can do the authentication. What are the 4 ways? Anyone? Yeah, demilitarization zones are also used. Can someone tell me what are the 4 ways of doing authentication? Categories, approaches. So this is a quick revision on security. Something user knows, like username, password, PIN number. Something user has, your card, access card, RSA token, or your mobile phone. So that is why we are sending the SMS to the mobile phone. If you have the mobile phone, you are the genuine user. So that is why we send it to the mobile phone. Has. Finally, something you say is biometrics. Retina scans, fingerprint scan, or loosely face detection. Something user knows, something user has, something user is. Okay. That is something we configure in the system. Okay. And there's another approach to do authentication, that is digital signing. That is also something user knows. Right? Digital signing or digital signature. Okay. So I'm just doing a quick revision also while doing questions. So likewise, you must have really high confidence now. Now, how do you do authentication? So what is authentication? Sorry, but authentication means make sure that only genuine users can access the system. Others are not allowed to access the system. What is mean by authorization? Anyone? So if you talk now, or at least chat using the Zoom chat, so that will improve your confidence. Otherwise, when the exam is 1 week away ahead, still you don't have the confidence. So this is the time to build it. So what is mean by authorization? So if you talk, it's easier, faster, but anyway, at least chat. Right. So there's one answer. Resources are given to relevant persons only. Yes. So authorization means access is given only to the relevant resources. So every user is not given access to everything. So you are given access only to the relevant things to you. So that is called authorization. So that is again something we configure in the system. So there are 2 ways you can do it. That is user base, role base. Right? User base and role base. So role base is the more practical approach when we have a lot of users. So then you must be able to explain the difference between user-based authorization and role-based authorization. Okay. Right. So then what is checksum, hash, or digest? So what is the property that we guard by having checksum? Or which aspect of security out of these 4 is guard by having checksum or digest or hash? It's the same thing. Which one? Yes, integrity. So we want to make sure that if someone third party has changed the content, we want to detect it. So that is why we have checksum, hash, or digest. So what is the idea behind checksum, hash, or digest? Now you should be able to draw small diagram and quickly explain it. So that is what is meant by studying. Studying is not reading third party notes like the note we have given to you. Of course, you need to do that initially, but now, so studying is your task. So you think about those things, answer those questions. What is it? Why do we need it? How to do it? How this is related to something else? So that is what studying. Adhyayane karna. Right. So you know that the checksum is related to integrity. So then how do we do it? How do we do it? What, why, how? So how do we do it? So when we have the content, we calculate a value that is called hash or checksum or digest. උන්ට මතකද මේ digest කියන වචනේ තේරුම මොකද්ද? කොතනින් වලට කතන්දරේ තේරුම් ගන්න මතක තියාගන්න ලේසි. What is the meaning of digest? Digest. Noun. Short report containing the most important facts. Collection of short reports, monthly news digest. Remember, there's something called digest. There was a magazine called Digest or Reader's Digest. I think it's no longer there. Okay. Digestive system කියනවද? ජීර්ණ පද්ධතිය. ජීර්ණය වුණාම ඉතුරු වෙන දේ අරකට represent කරනවා. Okay. So therefore what we do? We calculate a value, usually a number, which is a representation of the content and put it into the document itself. So then when it reaches the destination, it has the document and the digest. And now again the receiver calculate the digest using the same algorithm and check whether that your calculated digest is it same as the digest you receive. If both are the same, no one has changed it. If the digest you received and the calculated digest is different, that means someone has changed this. So that means integrity has been violated. So that is the idea. Okay, so then someone will say, okay, then what about if someone changed the content as well as digest? Right, as well as digest. Yes, then we are in trouble. But we, after adding the integrity or the digest, usually we encrypt also so that the others can't easily access it. Okay. Of course, they can change it. Then when they change something, the entire thing is changed. Okay, so that is the advantage of encryption there. Therefore, we add the digest and encrypt so that third party can't easily change the content and digest accordingly. Right, so that is checksum, hash, or digest. So then we have the encrypt. Of course, you know what is virus guards, what is firewall, and so on. So next we have the encryption, decryption. So what is the out of these, which objective is fulfilled by encryption, decryption? Anyone? Out of these four, which one is covered by encryption, decryption? Is it availability? Is it confidentiality? Is it integrity? Is it non-repudiation? Yes, it is confidentiality. Mainly it is confidentiality. Right. So when it comes, so what is meant by encryption, decryption? So this is my plain text. So this is my password. Say my password is say 123, but we don't send this plain text to the server. Because if I send the plain text 123, someone might read these data packets and analyze and identify, okay, this guy's password is 123. So therefore, the idea is we do something called encryption. Super simple question, concept. Right? So we do something called encryption. So this is called plain text. And when we encrypt it, we call it what? Anyone? How do you call it? Once you encrypt it. Yeah, ciphertext. Okay, ciphertext. Ciphertext. So that is after encryption. So this is not 123. This is some weird text. Maybe this is Q29 or Q2 hash. But this is not the password. This is encrypted text. This is sent to the other end. At ciphertext. Or Q29 or whatever. Okay. That is now decrypted to get the plain text back. That is 123. Like plain text. So that is called decryption. So plain text is encrypted to ciphertext at sender, and it is decrypted to the plain text back at the receiver. So that is called encryption, decryption. So this one, someone might be able to read it, but from that text, it can't, that person or that set of people cannot determine what is the real plain text is because it is encrypted. That is the idea. So that is what encryption, decryption, right? Simple as that. So then what is mean by symmetric or private key encryption and asymmetric or public key encryption? So in symmetric encryption, we use the same key for both encryption and decryption. Same key. Okay. Now this is what studying is. Adhyayana karna. So then you must ask, why do we need a key? Anyone? Why do we need a key? To encrypt, we need two things. What are those two things? Of course, you need the plain text, that is input. So to do the encryption, we need two things. That is, you need an encryption algorithm. So then you need an encryption key. Right? Of course, obviously, encryption algorithm is required to, that is some sort of a logic to change this to this. So that reverse logic, we can use it here, decryption algorithm. So that is obvious, right? We need an encryption algorithm. So then someone will ask, why do we need a key? Can't we just rely on the encryption algorithm? So this is what studying is. Now, can someone tell me why do we need a key? Whether it's private or public, why do we need a key? What is the advantage of having key rather than having just an encryption algorithm? So if you can answer these questions, you are now pretty much right. Prepare for the exams. Not to decipher text. That is not a correct answer. So my question is, can't we use the encryption algorithm and decryption algorithm alone to do this? And so why do we need both the encryption algorithm and key? To avoid unauthorized access is a general answer. That is not a proper answer. So I need a very specific. Right. So still I haven't got the proper answer. Maybe of, of course, whenever I ask question, don't use the chat GPT. Maybe you can ask from chat GPT. What is the advantage of having a key? So this is the answer. These encryption algorithms are quite complicated and at the same time well known. Okay, well known. So therefore, the hackers might guess maybe this is the encryption algorithm these guys are using. So therefore, they can, on the other hand, guess the decryption algorithm. So therefore, they might think, okay, this might be one of the well-known encryption decryption algorithm. So if they have used it, this is 1, 2, 3. This Q29 is 1, 2, QZ9 is 1, 2, 3. If they can guess the algorithm. Otherwise, you need to come up with new algorithms all the time. Coming up with new algorithms are not that easy. Okay, so therefore, relying on encryption and decryption algorithm is risky because people can guess it. Maybe this guy is using this algorithm. So what we do is we use well-known encryption algorithms. Basically, encryption algorithm is not a secret. But we use now two inputs, the plain text plus a key. Key is again a text, some sort of a text, secret text. So your encryption algorithm use both these text, your plain text and key to generate the ciphertext. So now the advantage is, so you need the same key or something related to that in order to do the decryption. Otherwise, you can't do it because this encryption key is a secret. So therefore, we don't, rather than keeping this algorithm secret, we just keep the key secret. So keeping the key secret is easier than keeping the algorithm secret. Other thing is, from time to time, we can change the key. Changing the key is easier than changing the algorithm. So that is why we go for use keys in encryption and decryption. So likewise, you must have the very specific answer. The best answer in the world must be with you. Okay. Right. So that is how encryption decryption is done. And that is why you need keys. So that we can keep the key secret easily and also we can change the key. time to time rather than changing the algorithm. Right. So my final question is, then what is mean by symmetric key and asymmetric key? Or another name for symmetric key is what? Private key. Another name for asymmetric key is public key. Okay, public key. So private key, symmetric key, public key, asymmetric key. Okay, right. So then you must know when to use symmetric key, what are the pros and cons? When to use asymmetric key, what are the pros and cons? So symmetric key means we use the same key for both encryption and decryption. Same key. Same key. And that is the easy approach, simple approach. Simple approach. Okay. So if this key is high, this key is also high. Of course, we can change the key time to time, but we need to use the same key. If you encrypt using PQ secret, decrypt also using secret. That is the simple approach, but this has a big disadvantage. What is the disadvantage? Since you are usually the keys are generated by the receiver. Now this guy generate this key and share it with the sender. And he or receiver use the same key. So therefore, when you share that key to the sender, of course you can trust you, but can you trust the sender? If the sender is a trusted party, okay, like your own company. But if the sender is a general public and normal person, so you can't trust. So therefore, you try to keep this secret. But when you share it with the sender, third party hackers might get it from the sender very easily. Because these guys may not be very conscious about security. So that is the disadvantage. So therefore, secret key or the private key is used when you have full control of both sender and receiver side. So that means you have full control. It's like your two branches where you have the full control. So then yes, use private key. Okay. Maybe just few users, trusted users with under your control. So then use private key because that is simple. But this has big loophole. That is, if hacker hack it from this guy sender, still now you are in trouble. Before you decrypt it, hacker can decrypt and get the secret data. So therefore, yes, secret key can be used when sender and receiver are trusted parties, or maybe just few senders which you can trust. But if not, we need to go for public key cryptography or asymmetric key. Another name for public key is asymmetric key. Another name for private key is secret key. Now, what do we do in asymmetric key cryptography? In asymmetric key cryptography, we generate key pair. Again, the receiver generated it. But the receiver generate two keys. But those two keys are related keys. They are not 100% independent keys. So this key depends on this one. But those are two different keys. So one is used for encryption. You call it, if this is A and B, we call it public key of B. Public key of B. So that is the key that we share with anyone or anyone in the world. That is why we say public key. We don't care anyone knowing this key. We publicly share it. Even hackers can get it easily. But other key is used for decryption. So we call it private key of B. Because both public and private has P, usually we use U for public, R for private. So B means B generate that. Public key of B, private key of B. And now these two keys are related because if you encrypt using this public key, it can be decrypted only using this private key because these two keys are related. but you don't share this private key to anyone else. So your private key is only with your server. So therefore, when someone encrypt using this key and get a private ciphertext, no one can decrypt. No one can, even the user sender itself can't decrypt it because the private key is only with receiver. So therefore, though you share this public key to anyone, no one can decrypt the encrypted data. Only you can decrypt. So that is the beauty of public key or asymmetric key cryptography. So therefore, when we use others to send their data to us, like we are having a website, say I am the Gmail, I am the YouTube, thousands of people's passwords they enter and we need to get it to the YouTube server. So we use public key cryptography. So the YouTube server has generated two keys, private key and public key. Private key is only with the YouTube servers. Public key is given to all. The same public key is given to all the users. I get that key, you get that key when you log into YouTube. But no one can decrypt it because only YouTube servers have the private key. And from time to time, periodically, they change this key pair for better security because anyway, this can be hacked. So therefore, maybe it depends once a month or something. So they again change these key pairs. But again, it's a public asymmetric key. Right. So any questions? So therefore, if there are million YouTube users, or all the people or all millions of users get the same public key, right? But only the YouTube server has the private key. In private key cryptography, we need to generate million key pairs. Otherwise, it is risky. But here, it is not risky. Okay. Any questions? Because we will not discuss this again before the exam because we can't do revision of revisions, right? Okay, got it? So use private key when you have just trusted senders, few. Use public key when you have general public accessing your system and still you want to encrypt and get the data securely. Okay. Right. So then what is digital signing? Digital signing is use of public key cryptography in the reverse way for authentication for different purpose. So what is simple answer? Digital signing is, if someone asks how the digital signing is done, we do the public key cryptography in the reverse manner for authentication. So public key cryptography and private key cryptography is for confidentiality, but digital signing is for authentication. So the only difference is now we have the plain text. This is signing algorithm. Signing algorithm. This is plain text. And this is sign text, which is sent here. And this is verification algorithm. So that is the reverse of signing. And we can get the verified text or maybe something like verified text or the plain text with verification. Okay, or verified text or the verified plain text. Now the difference is the two keys are generated by sender. For encryption, decryption, keys are generated by receiver, but now sender. So therefore we call it KRA, private key of A, public key of A. Now encryption is done by, signing is done by private key of A, KRA, which is a secret. A doesn't share it with anyone else in the world. But A share public key with anyone. So this is shared to anyone. Anyone interested can get it. KUA, public key of A. Now, when you sign using private key, the verification process, if it use this public key, the verification algorithm must say yes, verify. But if you use any other value, it will say not verified. Okay. So therefore, the receiver can check whether it is actually coming from A or not by getting the A's public key and using the verification algorithm. And if the verification algorithm says yes, verified, so that is genuinely coming from A, not from anyone else. If anyone else sending it, of course, that guy can sign it. But since that guy doesn't know this private key, that guy will not be able to sign it, so that this key will verify. As long as the receiver get the key of the correct sender, you can check whether it is coming from the real sender or not. So the difference is now private key is used for signing, public key is given to the receiver or receivers. In encryption decryption, public key is given to the senders, private key is used to decrypt. Okay. And even you can combine both those. So you can sign it using the sender's private key and encrypt using receiver's public key and send it. Then other side, it is decrypted using the receiver's private key and verified using sender's public key. So then we can make sure that it's both authenticated and confidentiality is assured. And even we can add here the digest also before encryption. So here then we can even verify the digest also. So that means we verify the authentication, confidentiality, and integrity also. Likewise, we can combine these things. Right. So therefore, digital signing is for authentication, and it is the reverse process of public key encryption, decryption. Any question? Any question? So when you visit a website, if it says HTTPS, so that means it is encrypted data you are sending. So in this case, Google has sent me its public key to my browser. My browser is using that public key to encrypt and send it. Only the Google server has the private key to decrypt it. So therefore, my data is not accessible. Of course, my data is accessible for the third parties in the internet, but they can't understand what I'm sending because it's encrypted, and only Google server has the decryption private key. Right. Any questions? Nothing? So therefore, the answer is in public key encryption system, each pair of communicating entities share the single key. No, if it is single key, it is not public key, it is private key or asymmetric key. Sorry, symmetric key. Another name for private key is symmetric key. Symmetric means same key. Another name for public key is asymmetric key. Those are related, but two different keys. So therefore, this is wrong, but B, C, and D are correct. So therefore, answer is fifth one, answer is fourth. Fourth. Okay. Right, sixth question. Consider the following statement. This is a networking question. DHCP server, remember dynamics host configuration protocol. So DHCP servers send the IP address to the devices. So remember, we can either assign our IP address statically in our machine, or someone else assign it as system administrator. That is the old approach. New approach is when we connect to the server or the router or whatever, it send me or it assign me my machine IP address. So that is called dynamically assigning IP address. Assigned from the server. So that server is called Dynamic Host Configuration Protocol Server, DHCP server. Usually DHCP server is running in your router or in a special network server, network machine. So it sends IP addresses whenever device is connected, it sends a dynamic IP address from the given range. So that is more convenient. Of course, it can send you dynamic IP or even it can send you static IP. If you have configured that this MAC address must always be given this particular IP address, so then DHCP service dynamically send a static IP. But most of the time, this will send a random IP from the range. So therefore, it's dynamic IP address, dynamically sending a dynamic IP address most of the time. But there's a possibility of dynamically sending static IP address. So then you need to configure that MAC address to IP address in the DHCP server. Right. Now let's read the questions, answers. Which of the above statement is correct? DHCP server in an IP network dynamically allocate IP address to a network device. That is exactly. DNS server translate domain name to IP address. Yes. So when I say Aurora CS.lk and enter, my laptop sends Aurora CSLK to the nearest domain server and asks what is the IP address. Because it can send data packet to IP addresses, not to domain names. So therefore, my nearest DNS server, with the help of other DNS servers, resolve the DNS name into the IP address of my server, which I have pushed to the servers through my domain name provider. So this is correct. FTP server caches the recently accessed web pages. Actually, FTP server is not a web server. FTP is FTP. FTP is FTP. So therefore, I will not take C. I will not take C. Because FTP server is not for caching web pages. Okay. So therefore, I will not take C. So therefore, I'll go for A and B only. But I think there's an issue with the past paper answer. Let's double check the answer. 6-1. Yeah. I don't know whether they change it later. According to my marking scheme, it says third one. Anyway, that is correct, right? Okay, that is correct. A and B only. I thought the answer is wrong. No, answer is correct. So the 6-1 answer is correct. Third one, right? Correct. Okay. So 6-1. The number is not printed properly, but anyway, that is the 6-1 because this is 7th and this is 5. So the answer is 3. A and B only. So any questions about that? So don't wait for me to ask any questions, right? If there is a doubt, even a slightest doubt, put it into chat or you can talk. Right, 7th question. Consider the following statement. Now I will little bit speed up also. TCP is a connection-oriented and reliable protocol. Yes, right? TCP is the reliable one. Connection-oriented. UDP is the less reliable or unreliable, a little bit more efficient protocol. Both are from the transport layer. Both are from the transport layer. So therefore, yes, TCP is a connection-oriented reliable protocol. UDP is user datagram protocol is a connectionless and unreliable or less reliable protocol. Correct. TCP and UDP are transport layer protocols. Yes. Remember, IP is network layer. TCP or UDP both are in transport layer. Every application use either TCP or UDP. No application use both. But every application use IP from the network layer and from transport layer, it use either TCP or UDP. But most of the application use TCP, like HTTP, FTP, SMTP. They need reliability. Only few applications use UDP, like DNS. So, හොඳට මතක තියාගන්න DNS කියන එක තමයි ප්‍රසිද්ධම එක්කෙනා UDP පාවිච්චි කරන්නේ. මොකද ඔය එක්සෑම් එකේ අහන්න පුළුවන් ඊට පස්සේ. අහන්න පුළුවන් කියන්නේ අපි දන්නවා ඩිග්‍රී ලෙවල් එකේ ක්වෙස්චන් වල ඔවා තියෙනවා. ඒවා තමයි ඊට පස්සේ ඔයගලෙන් අහන්නේ. Maybe you can put up a small note. Easier thing is just put up a note which application protocols use UDP because there are only few. So if it is not in that list, by default, it use TCP. So let's ask on ChatGPT. ඔයගොල්ලෝ දැන් පුරුදු වෙන්න ChatGPT එක වැඩ කරන්න, right? ඔක්කොම අහන්න ඕනේ නැහැ. වගේ අපි අහමු මොනවාද මේ ප්‍රසිද්ධ protocols, application level protocols UDP use කරන්නේ. Right. What are the famous නැත්නම් ලොකු list එකක්ද application protocols or applications කියන්නත් පුළුවන් මට application protocols that use UDP ටිකයි තියෙන්නේ DNS අනිවාර්යෙන් ඇති right you can see DNS DHCP වෙනවා DNS ඔක ලියා ගන්න පොඩ්ඩක් note එකක් දාගත්තොත් හොඳයි DNS DHCP TFTP ඒක නම් ඔයාලට ඕනේ නැහැ maybe SNMP right so they basically these protocols are used for network management and IP management domain name to IP translation just keep these only just remember keep a note of this what are the application protocols that use the UDP just remember DNS DHCP SNMP NTP VoIP and any other streaming media right real-time streaming protocols like Zoom for example Zoom use UDP because it's very important that you get the data packet because it's a live session right so basically when we do real-time communication like streaming audio video streaming we use UDP then we use network management applications like SNMP NTP use UDP then when it comes to domain name translation and IP address related things that is DNS and DHCP use UDP all other that is HTTP FTP SMTP that is email POP IMAP all other serious applications use TCP okay right so let's move on so the answer is all are correct 7 5 5 eighth one in the OSI reference model the network layer is responsible for right so this is a little bit debatable question all right so let me draw the OSI layers again for you guys I will draw it here remember OSI architecture is a 7-layer architecture 7-layer architecture 1 2 3 4 1 2 3 4 5 say 6 7 1 2 3 1 2 3 4 5 6 7 so this is application let's go from down physical logical or data link network transport session presentation okay session presentation and application okay right so it's talk about in the OSI reference model the network layer is the third one right third one that is where you have the IP address IP packet router operate in this layer right so this is where you have the bits communication or signals so remember physical layer we discussed how the signals are encoded then modulated and multiplexed and other side multiplex demodulate and decoded so those are the physical layer link layer is all about how to use the shared media like Aloha right CSMA CD how to use the shared media and this is where you have the MAC address and frames data is here sent as bits or waves but here it is data frames and here we have MAC address here we have data packets and data packets have the IP address, not the MAC address. The IP address can be identified by routers to route it long distance, because IP address, public IP address, has a geographical meaning. MAC address has no such thing. MAC address is just a serial number. So likewise, you must be able to explain this OSI architecture. How do you use OSI architecture to understand network? Right. So these are the two ends, maybe sender, receiver. But the intermediate nodes are either switches or routers. Switches or routers. So that is the standard terminology. So remember, link layer concepts are interested by these intermediate switches. Network layer concepts interested by routers. Of course, physical layer, any of these, because the signal goes from one switch to router to blah, blah, blah. But from this point onwards, from network layer onward, that is transport layer onwards, it is end to end. Two ends do the communication. The intermediary nodes have no interest about these concepts. So here TCP port, TCP port. So that port is, others don't care about the port number. Okay. And of course the HTTP and so on. So therefore for these three layers, these intermediary nodes are interested about those concepts, but these concepts are only for the two ends. The switches, routers, and has no concern about these things. Remember, UDP, TCP is also to make a connection. Connection is between the two ends. Right, now let's read the answer. Anyway, this answer is a little bit debatable. I think it's poorly worded question. Okay. In OSI reference model, the network layer is responsible for network layer. So that is this layer. IP packets are there. Communicating which of the following is suitable? Node to node. So node to node, source to destination. Usually source to destination is from here to here. Maybe this is your web browser client machine, your laptop or smartphone. This is the web server machine. So that is source to destination. Remember, they talk about network layer. Network layer is every intermediate node is interested about the network layer concept. For example, data packet goes from here to here, here to here, here to here. So therefore, it is not source to destination, no, the source to destination is basically these layers. That is transport, session, presentation, and application. So therefore, this is not source to destination. Okay. Now we have a little bit of confusing word. Hop to hop, process to process. Process to process means process running here to process running here. So therefore, it can't be process to process, because network layer is these intermediate routers are interested. So therefore, at least I can eliminate source to destination. No. Process to process means client running program to server. Those are upper layers. Then it says switch to router. Switch has no concern about network layer because it's IP. Routers, yes. So therefore, I don't like the word switch to router. Now, this is little bit debatable words. Hop to hop, node to node. Okay. Node to node. So I'm not very sure what the examiner mean by hop to hop. Because sometimes we use these as nodes or hops. In that case, I feel like both 1 and 3 are correct. But I think examiner has taken one of those as answers. Maybe there's a very precise definition. Anyway, let's ask ChatGPT, what is node, what is hop in computer networking? Maybe ChatGPT can clarify. Of course, in the exams, you don't have that facility, okay? In networking, what is a node and what is a hop? Because this hop is little bit rarely used word. So it says node and hop are fundamental concepts. A node. So node means more a end computer. Any device or data point that can send, receive, or forward information over the network. So it can be a computer. We can see node can be a network router also. So that is okay. So that means node can be a end computers or routers, switches, IoT devices, smartphones, of course. Then what about the hop? So that means the node to node is a possible answer there because node has switches and hubs and routers as well because yes, they are interested about that. Okay. So therefore, possibly the answer is node to node. But anyway, let's look at what is hop. Hop refers to the action of data traveling from one node to another node within a network. So that means you can see that hop is also very much related to node. Right? So hop refers to the action of data traveling from one node to the other node. So therefore, you can see that node to node and hop to hop has a lot of similarity. Right. But anyway, let's read. Single hop, when the data is sent directly from one node to the other node with no intermediary nodes, it is considered single hop. Multiple hop, when data travels through multiple nodes like routers or switches before reaching its final destination. Okay. So again, hop can be single hop, multiple hop. But that is why I told you hop and nodes are pretty much the same thing. Pretty much the same thing. So therefore, I'm confused whether the answer must be hop to hop or node to node. Okay. So let's check the answer because I'll go for node to node, but I'm not very sure. I'm not very sure about the answer. I'll go for one, but let's check the answer. Okay, 8. Yeah, yeah. Possibly answer is 1. Okay, because I don't think that it can't be 2 or something. Possibly answer is node to node. I think there are some confusions about that answer. Okay, so most probably answer is node to node. Right. So these 3 layers are pretty much node to node layers. These 3 layers are pretty much source to destination or process to process layers. Process means running program here to running program here. Intermediate devices has no concern about whether it's TCP, UDP, HTTP, session, right? Connections, no. Okay. Right. So any questions? Anyway, the answer is a little bit debatable. So always the networking questions are very challenging. So usually students consider networking questions as the most difficult. Most of the students consider. Right. Which of the following indicates the number of host bits and number of IP addresses respectively in a class C network? Anyway, these days we don't care much about the classes. But anyway, this is 2018 paper. Anyway, we discuss classes. Remember class A. So that is where do we break this? Class A means this is the place where we break it. Class B means this is where we break it. Class C means this is where you have this is net ID, host ID, net ID, host ID, net ID, host ID. And of course, from here we can borrow to create subnetwork, okay, in class full. So therefore, class C means the net ID to host ID separation is here, or the default mask is 255.255.255.0. Okay. So therefore, these are the last 8 bit is for host. Of course, we can use all those 8 bits and create one subnetwork, or you can borrow some of these bits for creating subnetwork. That is the whole idea behind subnetting. We discussed that. So the question is, Which of the following indicates the number of host bits, that is 8-bit, and number of IP addresses, that is 2 to the power 8. Because 8 bits means, that means we are not creating subnetworks. We are creating that as a one subnetwork. If you want to break it into smaller subnetwork, we further divide it. Then net ID, subnet ID, and host. So that is where we have the subnet mask for the CIDR notation value. But this question is assuming that no, we don't break it into subnet. We use the entire IP address block as a one subnetwork. So then we have 8 bits. 8 bits means you have 2 to the power 8 possible combinations. So 2 to the power 8 means 2, 4, 8, 16, 32, 64, 128, 256. Right, 256. So therefore 8-bit 256. Of course, out of 256, we need to reserve 2 addresses, but examiner has not considered that also, because usually that reserving is considered for subnetting. Okay. Ideally, it should have been 254, but anyway, examiner has loosely taken it as 8 and 256. So 9th question answer must be 1. Any questions about that? No? Class A, Class B, Class C, Class B. So this question is also class. These days, examiner usually doesn't ask much questions about classes, because now we have pretty much get rid of the concept of classes. But anyway, this is another class related question. To which of the following network class does IP address this belong to? So you need to just look at the first value. Right. So remember, we discussed that. So network, make sure you take the latest node from the Google Classroom, okay? Because I have done changes and I will keep changing. In the next few weeks, I will physical layer node is there, okay? I think logical link layer node is also there, but other nodes I will be adding in the coming weeks, okay? Coming weeks. That means new nodes. Of course, you already have the nodes, but you will be getting fresh nodes as well. But every time a new node is added from today onwards, I will inform you. So therefore, maybe you can take the nodes today, all the nodes today, the latest. So then if I do a change, I will definitely inform you, saying that this node is updated. So therefore, take that new one. But there won't be much changes before your exam. But definitely there will be some new nodes, of course, for your e-business and new trends. Okay. Right. So that concept is under network layer. So we did all these calculations. Okay. So how do you identify the class? Class A is 0 to 127. Class B is 128 to 191. Class C is 192 to 223. And class D is 2242 to 239. Class C is 240 to 255. So that you need to remember. So therefore, this question is under 192 to 223. 192 to 223. Because this 192. So therefore, this is a class C address. You just need to look at the first octal. Answer is class C. Answer is third one. Yes, third one. Okay. Right. 11th question. In OSI reference model, a protocol data unit. So protocol data unit is the one that I mentioned here. This is here protocol data unit is bit. Physical layer protocol data unit is bit. Link layer protocol data unit is a frame. Right. In network layer protocol data unit is data packet or datagram or IP packet. So here usually protocol data unit is called segment. but usually we don't care about upper layers. So bits, frame, data packet or data gram or IP packet, segment. Okay. Protocol data unit of the network layer. So network layer protocol data unit is what? Data packet or IP packet. Not a frame, not a segment, not a window, not a message, packet. IP packet or data packet. Answer must be 5. Yes, answer is 5. Packet or IP packet or data packet or IP datagram, same thing. Right, so that's the end of the networking questions. Usually networking questions are challenging because network questions you can't memorize and do. Network questions you need to understand the subject. That is why we took a lot of time for doing network. Right. 12. Which of the following correctly lists the given computer storage components in descending order of access speed? That is super easy question. Remember descending. Ascending means lower to higher. Descending means higher to lower. That is higher speed to lower speed. That is higher speed is when you are getting closer and closer to the processor. Processor. So therefore, you must start it with probably registries, then cache memory, then main memory, then magnetic disk or any other secondary storage. So therefore, answer is obviously so this one cache memory is here wrong. Answer is 4. Answer is 4 because it's descending. Bigger to higher speed to lower speed. Higher speed to lower speed. Answer is fourth one. Fourth one. 11. Consider the following computer memory types. Just read the question first, right? Rather than reading this. Which of the above are volatile memory types? That is super easy. Volatile means when the main power supply is disconnected or switch off, still the content remains. Content is not vanish. Right? So that is what is meant by volatile. CMOS memory, yes. Firmware. There's a small battery for that. Cache memory, no. Flash memory, yes. Flash memory is basically your SSD, right? Flash storage. Hard disk, yes. RAM, no. Registries, no. So therefore, I'll go for A, C, and D. That is first. I'll go for 1. Examiner has taken 4. Right. Sorry, volatile. Sorry for that. So what the examiner is looking for is volatile. I look at the completely opposite answer. So volatile means B, E, F. Right. So what I mark is a non-volatile. Examiner asks volatile. So therefore that is unfortunate, right? Don't do that kind of mistakes in the exams. So the volatile storage are B, E, F. It's completely opposite of what I mark. Okay, B, E, F. Sorry for that. Okay. Right. 14. Consider the following statement regarding HTML. Right. HTML. HTML frames are used to divide a browser window into multiple sections. Yes. So you can use to break it in horizontal manner or vertical manner. Remember, we can say 25%, 60%, and blah, blah, blah. But these frames are no longer used much because there's a better approach called iframes. It can be anywhere. Right? The frame can be anywhere or any shape. But these are the traditional frames. Right? Traditional frames. So the question is about that usually we don't use much traditional frames. For example, this is a traditional frame. If you go for something like, say, Java API doc. So this is a traditional frame. So it has been subdivided into two vertical zones, and that vertical zone has been subdivided into two horizontal zones. So this is traditional frames and nested frames actually. But the new iframes are, if you go for something like Gmail, right? You have, for example, when you go for Compose, right? Compose. So this is iframe. You can see it is iframe. So it can fit into any place. It can be maximized and so on as well. So iframes are more flexible. So therefore we heavily use iframes. Okay. So another iframes are used in social media and so on. Okay. Right. So let's read the question. HTML frames are used to divide browser window into multiple sections. Yes. Right. That is the idea behind frames. And we can load different pages also to different frames. The rows attribute of frame set tag defines the number of vertical frames in the HTML page. No, its rows means not vertical frames. Rows means horizontal frames. Like row means horizontal. Calls is vertical. So that is wrong. This is calls. Frame set calls 100, 500, 100 create vertical frames with specified number of millimeters. No, not millimeters. Okay, it must be percentage. And therefore, this is also not, it looks like this is also not tallying into 100 also. So usually it must be something like maybe 50, 25, and 25, and so on. Percentage. Okay. Because different screen size have different screens have different sizes, different resolutions. So preferably you need to give it as a percentage. Therefore, anyway, definitely not millimeters. So we don't use millimeters in web development. Either percentage, relative size, or pixels. And there are a few other units also. So therefore, this can't be millimeters. So therefore, I'll go for A only. 14, 1. Yes, 1. Right. Another HTML question. It looks like definition list. We did this, right? So what are the three type of lists? Ordered list, unordered list, definition list. So this is a definition title, definition data. Right. Consider the HTML code with labels 1 to 3. What is the correct order of tags to replace in the 1, 2, 3? That is super easy. So 1 must be definition list DL slash DL. This must be definition title DT. This is definition data. Again DT DD. So 1, 2, 3 is DL DT DD. Right? DD. Definition list, definition title, definition data. DL DT DD. So DL DT DD is the second one. 15th answer must be second one. Yes. So this is not a difficult question, right? Paper, right? I don't know how do you feel it, but I don't think that this is. So this is something you can go for even 100 out of 100 if you have done proper studies. We have covered all these concepts. Okay. So when you go for ICT, maybe you can get 100 out of 100. Consider the following HTML code for creating a table. Again, we look at the answers. So what is the output? Okay, which one will be the output? First of all, you can see there's a style which is defined in the head. Okay, head close, style, a table tag, comma is there. That means for table tag, th tag, td, border must be 1 pixel, solid black. Right, so that means it must the border must be everywhere, not just outside. No. All rows and columns must be having because th, td, okay. Both are there. Both are there. But no TR, right? So that is strange. No TR. TR මෙතන නෑ හැබැයි, yeah. I think you don't need it for TR when you have it for TH and TDs. Anyway, both TH and TDs there. And table means the outer border. Outer border. Okay. Yeah. So therefore, this should cover all the borders. Right. So then you have row span also. That also you need to look at. So therefore, I will not take these two because they don't have the border. Now look at where do we have the correct row spanning. So first one is first TR, you have TH and TD, name and command. So this is my, remember TH is center line. And bold. This doesn't look bold, this doesn't look bold, but this look bold. Okay. So TH must be bold. I don't know, is it bold? Not very sure. But this look bold for me. Okay. Anyway, let's draw it. Kamal. This must be left align. Kamal. And left align, left align. Okay. So it is not name telephone. It's name Kamal. So this is also wrong. So I'm just eliminating some answers. Then second one, row span is 2. That means it must take 2 rows. So therefore it can't be something like this. It must be something like this. So hopefully then this is also bold. Okay. Because it must take the next row also. Okay. And it must be telephone. And it is TH. It must be center line because it take the full width. Anyway, that it doesn't matter. So then you have the first TD, this. Other TD is for this because this has to row span to this. It looks like this is the answer. This is the answer. I can assume that this is bold, though it is not very clear because this can't be, because here you have your T row span 2 is not used. Okay. So there the data is wrong. There the border is missing. So I'll go for 1. 16, I'll go for 1. Yes, 1. Right. 17. So that should be an easy question. Which of the following is the correct HTML state for inserting an image? So when you insert image, we use IEMG, not image. There's nothing called image tag. So this is straight away wrong. Okay. Straight away wrong. And also we use SRC, not href. Not href. So it must be SRC. So you can't have the image here. Right. So it must be SRC. And of course, you can have the alternative text. Right. In case image is not loaded, that text will be displayed. So this one has the ALT, but not the SRC. So this is wrong. And this one has the SRC, correct. ALT there, but here you have the SRC and href both. Do you need href? No, right? You don't need it. What you need is SRC. So href is needed if you want to make it a hyperlink. Then you need to have the A tag, and for that you need the href. So no point having href for the IMG. So therefore I'll go for 3. So this is only the starting tag. Ending tag is not there. But ideally ending tag must be there, or you need to make it like this. But the examiner is a little bit vague. Ideally should have been having this kind of a link or closing tag. But remember, HTML is not strict about the well-formedness rule. So therefore, loosely we can take this as an answer. Okay. 17 will go for 3. Yes. Right. 18. What kind of a question is this? Consider the space voyage for landing a human being on the surface of the moon for the first time in 1969. The entire event was broadcast on the radio, in Sri Lanka by several commentators based in Sri Lanka and USA. Okay. So even in 1969, it looks like they have live broadcasting in Sri Lanka. Okay, maybe. Which of the following event relates to the highest value of the information? This is about the value of information. Okay. Which of the following events relates to the highest value? Remember the highest value, we discussed the value of information, right? So the highest value is at the information creation time. When the time passed by, value goes down in general. Okay, in general. And of course, highest value is when the information is complete, simple, right, reliable, secure. So that is where the people get the value. Right. So the question is, which of the following events relate to the highest value of information? Counting down for the launching of the rocket that carries the space shuttle. Okay, so let's keep reading. The moment the space shuttle escaped from the gravitational field of the Earth. Okay. So what is the highest value usually? When that guy step on the moon. That is what everyone is looking at, right? Because this is not just sending a rocket to the space. Anyway, let's see. The moment the space shuttle entered the moon's gravitational field, okay? The moment the astronaut Neil Armstrong placed his first step on the surface, yes. So that is what everyone is interested, because that was the objective. Because even before this, we had sent rockets to the space. This is the first time we sent a man to moon. The moment the astronauts landed on the sea in their return voyage, of course, that is also important, but the highest value is this information. Giving this information fast, reliable, complete, simple manner. So most probably the live telecast was about at this movement, not the other movements. So the answer must be fourth one. Yes. 19th. Consider the following statement related to development of computer over time. Which of the above statement is correct? Both processing speed and power consumption of the computer have increased. In a way, yes. Right? Processing speed, definitely yes. But when we do more and more processing, usually we need more and more power. But we try to reduce it. So therefore, in a way, it's a little bit debatable answer as well. So yes, it has increased, but at the same time, we try our best to reduce it also. But in general, I feel like the power consumption is also getting high. Okay. Right. B. Processing speed of a computer has increased, yes, while physical size of a computer has decreased. Yes, that is correct. So in general, physical size has decreased. Both power consumption and the physical size of a computer has reduced. Definitely, the physical size has reduced. But power consumption, has it reduced? I don't know. I think yes, right? Early days computers use a lot of power. Man. I think relative to the processing, power consumption has reduced. For example, if you take smartphone, so we can just charge it and use it for maybe days. So therefore, in a way, yes, right? Power consumption has reduced, right? Because now we use more and more battery charge. Because once you charge, we can use it for, even sometimes there are laptops where we can use it for 12 hours. I think yes, right? So now we can charge. About 5-10 years ago, when we charge a laptop, we can use it for only about 1 or 2 hours. But now we have laptops. When we charge it, we can use it for some time. There are some laptops even we can continuously use for 10 hours and even more. So therefore, anyway, let's take it, right? Because if you look at it reality, uh, when we charge it, now we can use it a longer time. So that means basically power consumption is getting less, right? So therefore, yeah, anyway we'll take it. Okay. Anyway, we'll take it. So then perceived speed and power consumption has increased. Okay, let's not take it then. Process speed of a computer has increased while the physical size of a computer has decreased. Okay, we'll take that. Both power consumption and physical size. Okay, physical size has definitely decreased, reduced. Maybe we can take that power consumption also reduced, right? So that is why the battery life is getting higher and higher, right? And with very small charging cycle, we can keep our smartphone up and running for another 1 or 2 days. I'll go for B and C. B and C is there. So is that the answer? 19. Yes, examiner's answer is also B and C. That means examiner has also accepted that, considered that power consumption is getting. I think that is fair. That is fair. Remember, when it comes to the first generation, second generation computers, so the main issue was heat consumption, right? So the computers were of the size of cabinets or rooms. But now the computers are getting smaller and smaller, means we need less and less power. Okay. Yeah. So therefore, it's fair answer. 4. Okay. Right. 20. Consider the following statement. So this is about the ethics and security, privacy. Okay. Which of the above statement is a valid? Providing a personal information of customers stored in a computer by a vehicle servicing center to an insurance agent, that is violating the privacy. So you collect data and give it to another party. An issue related to privacy of customers, of course, yes. So that you are compromising the privacy and you are doing sort of a cheating, right? Giving unfavorable advantage to insurance companies. Yes. Providing a copy of single user license software to another party is a piracy issue. Yes. Because if it is a single use license, you are not supposed to share the license with another one. Okay. Copyright. Yes, it's a copyright violation. Unauthorized access to another person's computer is both illegal and yes, both illegal and unethical. Right? Unauthorized use means even Sri Lanka, it is illegal under Computer Crime Act. So I'll go forward. 20, I'll go for 5. Yes, answer is 5. Right. So the rest of the questions, I think we are in the halfway. We will cover. Maybe next class we can either do 100% business studies, business that our topic, or maybe we can quickly do the rest of the 20 questions. Or no, I think the rest of the 20 questions will take a little bit more time because we have database questions and program. We will decide. Okay, maybe we can do quizzes, this paper, or maybe we can 100% concentrate on the our other topic, and then again come back to this maybe week after. Okay. So make sure you guys attend the classes on time because otherwise you waste your time as well, right? We stop at this point, right? Thank you.